Hello there, and a very gentle welcome to the Serene Scroll. I'm so glad you could join me. Perhaps the day has been full, and you are now seeking a quiet harbor, a place to let your mind soften and drift. Find a comfortable position and allow the weight of your body to be held to feel secure. There is nothing you need to do, nowhere else you need to be. Just before we drift into our story tonight, if you find a sense of peace in these quiet journeys, a gentle tap on the like button and subscribing to the channel helps these stories find others who might need a moment of calm. Now let us begin. There is a deep comfort in a finished map. In the crisp lines that define a coastline, the shaded contours that show a mountain range, and the familiar names that mark a city or a town. A map tells us where we are. It offers a story of completeness, a sense of a world known, measured, and understood. For centuries, humanity worked to fill the blank spaces on our own world's maps, to sail beyond the horizon and replace the phrase, "Here be dragons," with the names of rivers, islands, and continents. We have always been driven by this quiet, persistent need to know what lies just beyond the edge of the light. And for a long time, our map of the solar system felt almost complete. Imagine our cosmic neighborhood as a vast, dimly lit room. In the center, there is a single brilliant lamp, our sun. Close to its warmth, we can clearly see the familiar furniture, the small rocky forms of Mercury, Venus, Earth, and Mars. A little further out, we can make out the grand, heavy shapes of Jupiter and Saturn, their presence immense and reassuring. We know these pieces well. We have measured their paths. We know their textures, their rhythms. They are the known world. But as our eyes adjust to the deeper twilight, toward the far walls of this room, things become less certain. In the late 18th century, a new shape was found in the gloom, the pale, serene orb of Uranus. It was a stunning discovery, pushing the boundaries of our known world further than ever before. For the first time in recorded history, the map of our solar system had grown. Yet this new world brought with it a new mystery. As astronomers traced its long, slow journey around the central lamp, they noticed something was not quite right. Uranus wobbled. It strayed from the path that our laws of gravity insisted it should follow. It was like watching a dancer who, in the middle of a perfect pirouette, is gently but inexplicably pulled aside by an invisible partner. This subtle, ghostly tug was not a flaw in our understanding. It was a clue. It was a whisper from even deeper in the darkness. The mathematics was clear. Something else had to be out there. Something large enough and massive enough to exert its own gravitational pull across billions of miles of empty space, gently shaping the path of a giant. Our map, we realized, was still incomplete. There was another piece of furniture in the far corner of the room, one we had never seen, but whose presence we could now feel. This is where the story of Pluto truly begins, not as a discovery, but as an idea. It began not with a telescope, but with a pen and paper, with calculations and predictions. It was an act of profound intellectual faith, a belief that the universe was orderly, and that the language of mathematics could reveal a world before our eyes ever could. The solar system, which had felt so comfortingly familiar, suddenly had a new edge, a new terra incognita. Out there, beyond the orbit of the seventh planet, past the boundary of all we could clearly see, lay a ghost, an echo in the dark. The search for this unseen world was not just a scientific endeavor. It was a testament to our innate human curiosity, that same drive that sent ships across uncharted oceans. It was the desire to turn a whisper into a voice, a shadow into a form, to fill in that last distant unknown region of the map. This echo now had a name, a placeholder for a mystery yet to be solved, Planet X. And finding this ghost in the grand cosmic machine would become the great astronomical quest of a generation. Our solar system, as we once imagined, it was a place of elegant clockwork precision. The great planets moved in their celestial grooves, following paths laid out by the invisible laws of gravity, as predictable as the turning of a finely crafted watch. But by the turn of the 20th century, a subtle disturbance was felt, a ghost in the grand machine. It was a tiny persistent error in the orbits of the outermost giants, Uranus and Neptune. They did not move quite as they should. They wobbled, they strayed, pulled by a whisper of gravity from something unseen, something hiding in the profound darkness beyond. This cosmic detective story begins not with a telescope, but with a pen and paper, and with a man of immense wealth and even greater conviction, Percival Lowell, an heir to a Boston fortune. Lowell was captivated by the heavens, and he poured his resources into building a private observatory under the pristine high-altitude skies of Flagstaff, Arizona. There, on what would come to be called Mars Hill, he established a base of operations for what would become his life's great obsession, the hunt for the phantom world he called Planet X. Lowell was not chasing a wild fantasy. The method had a noble precedent. Decades earlier, the planet Neptune had been discovered. In precisely this way, its existence was predicted, mathematically based on similar wobbles in the orbit of Uranus, before it was ever confirmed by human eyes. It was a triumph of reason, a testament to the power of the human mind to map the unseen. Lowell believed he could do it again. He became a celestial detective chasing a suspect he had never seen armed only with a mathematical profile and the subtle gravitational fingerprints it left behind on its neighbors. The work was a quiet, painstaking form of intellectual devotion. Lowell and his team of assistants, known as computers, would spend endless hours hunched over ledgers, their pages filled with sprawling, intricate equations. They were trying to calculate the location of an unknown world from the faintest of clues. It was like trying to find a single specific grain of sand on a vast beach by measuring the subtle way the tide pulls around it. The calculations were immense. The possibility for error was constant, and the predicted locations for Planet X shifted with every new refinement. When the mathematics provided a target, the search moved to the telescope. But this was not the simple act of looking through an eyepiece. The process was a testament to human patience. Astronomers would aim the telescope at a small patch of the star-dusted sky where Planet X was thought to be hiding. They would open the shutter and expose a large, heavy glass photographic plate, sometimes for hours, letting the faint light of distant stars burn their images onto the emulsion. Days or weeks later, they would photograph the very same patch of sky again. Then came the most grueling step. The two plates were placed side by side in a machine called a blink comparator. Looking through its eyepiece, the operator could rapidly switch the view back and forth between the first plate and the second. Against the backdrop of thousands of stars, all fixed and unmoving, a planet would betray itself. Because it had moved in its orbit between the two exposures, it would appear to jump to blink while everything else remained still. Night after night, year after year, Lowell's team scanned the plates, their eyes straining in the dark, searching for that one telltale flicker. But the ghost remained elusive. The sky offered up its distant galaxies and ancient stars, but Planet X was nowhere to be found. Percival Lowell died in 1916, his great hunt unfinished. He had dedicated the final decade of his life to the search, and he left behind not a discovery, but an obsession, a legacy of meticulous calculations, a library of glass plates, and a powerful idea that refused to fade. His quest for Planet X was written into the very mission of the Lowell Observatory. Though its leader was gone, the search was not abandoned. The ghost still haunted the frozen edges of the solar system, and the tools to find it were still there waiting patiently under the Arizona sky. The vigil continued, and somewhere in that vast, silent archive of the cosmos captured on glass, a single impossibly faint flicker of light was waiting for a new pair of eyes to see it. The gravitational whisper from the edge of the solar system became a call, a challenge issued to the world of human astronomy. The hunt for Planet X was on. The search would not be a matter of grand sweeping gestures, but of quiet monastic dedication. It would find its home high on a mesa in the clear, cold air of Arizona at the Lowell Observatory, an institution built upon one man's fervent belief that another world was waiting to be found. And it would fall to the eyes not of a seasoned professor, but of a young man who had learned the heavens from the vast, dark skies of a Kansas farm. His name was Clyde Tombaugh. In 1929, he was just 23 years old, an amateur astronomer with a passion that burned brighter than any formal degree. He had built his own telescopes from spare parts, grinding the mirrors by hand, and with them he had created drawings of Jupiter and Mars, so detailed, so precise, that they captured the attention of the astronomers at Lowell. They offered him a job not as a lead scientist, but as a technician tasked with one of the most laborious and mentally exhausting jobs imaginable, to systematically photograph the sky, and then to compare those photographs, speck by painstaking speck. The tool for this task was a machine called a blink comparator. It was a clever, intricate device, a kind of celestial time machine for the eyes. It held two large glass photographic plates, each one a frozen moment of the night sky, taken several days apart. Looking through the eyepiece, an operator could flick a switch, and the machine would present first one plate, then the other in rapid succession. The effect was like a flip book of the cosmos. The distant true stars fixed in their ancient positions would appear perfectly still. But anything closer, an asteroid, a comet, or perhaps a planet, would have moved in its orbit between the two exposures. Against the static backdrop of a million unmoving stars, such an object would appear to jump, to flicker, to betray its motion. For month after grueling month, Clyde Tombaugh sat in the cold, dark dome, his eye pressed to the comparator. The machine would click and clack, a steady mechanical rhythm in the immense quiet. Each pair of plates was a universe unto itself, containing hundreds of thousands of points of light. He scanned them methodically, row by row, his mind trained to ignore the static and seek the flicker. It was a search for a single, impossibly small anomaly in a sea of cosmic perfection. He scanned through the star fields of Gemini, his gaze tracing a path through the heavens where calculations predicted the phantom planet might be. Days turned into weeks, weeks into months. Millions upon millions of stars passed before his eyes, each one a still, silent constant. And then, on the 18th of February, 1930, it happened. In a patch of sky he had examined before on plates captured in late January, his breath caught in his throat. Amidst the steady, unblinking star field, one tiny speck of light did not hold its place. As the machine switched between the two plates, this faint mote of light hopped, a tiny rhythmic jump back and forth, back and forth. It was small, impossibly distant, but it was unmistakably moving. He stopped the machine. He checked the plates, his heart pounding a quiet, steady drum against his ribs. He measured the shift. Everything confirmed it. This was not a flaw in the glass. It was not a passing asteroid. It was a world. After a year of relentless searching, the ghost had shown itself. The flicker of light was real. The news was confirmed, and then it swept the globe. A ninth planet had been found orbiting in the profound frozen darkness beyond Neptune. But this discovery was not an end. It was a beginning. The flicker of light on a photographic plate had given humanity a location, an address in the cosmic dark. But it offered no details, no sense of character or scale. The tiny dot was a mystery, a question mark hanging at the edge of everything we knew. It had been given a name, Pluto, after the Roman god of the underworld, a fitting title for a world that resided so far from the sun's warmth. And for decades to come, that is all it would be, a name, a myth, and a faint solitary point of light, the lonely king of a realm we could see, but could not yet touch. And so the discovery was made. The grainy photographic plates captured in the biting cold of an Arizona winter held a ghost. A flicker of light that had shifted its position against the steadfast tapestry of the stars. Planet X was found, and it was given a name that echoed its home in the dark depths of space, Pluto. With its discovery, a sense of completion settled over humanity's map of the solar system. There were 9, a neat and satisfying number: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and now Pluto. It was the final world, the farthest shore, a small defiant period at the end of a grand celestial sentence. For decades this was its identity. It was the last stop, the lonely king reigning over the immense empty territory beyond the gas giants. But this king was not like the others. Its rule was eccentric, its path a departure from the grand orderly procession of its planetary siblings. While the other planets traced nearly circular flat paths around the sun, like skaters on a frozen pond, Pluto's orbit was a wild, tilted ellipse. It was a long, looping journey that took it soaring high above the plane of the solar system and then swooping down below it. For 20 years out of its 248-year journey, this tilted path would even carry it inside the orbit of Neptune, making its neighbor for a time the most distant known world. It was a maverick, an outlier, whose very existence was a quiet rebellion against the tidy rules we thought we understood. For nearly 50 years it remained a solitary point of light in our most powerful telescopes, a mystery wrapped in cold. We knew it was small, far smaller than any other planet, and we presumed it was a simple inert ball of rock and ice. A geological tomb, frozen solid at temperatures that would turn the very air we breathe into a solid block. It was a world without weather, without change, without a story. A monarch on a frozen throne ruling over a kingdom of absolute silence. Then, in 1978, the story grew more complex. The lonely king was found to have a companion. Astronomer James Christie, examining highly magnified images of Pluto, noticed a strange bulge, a recurring elongation. It was not a flaw in the telescope, but a moon so large, nearly half the size of Pluto itself, that it did not simply orbit its parent. Instead, the two worlds orbit a common point in space that lies between them. They were a pair. This colossal moon was named Charon after the ferryman in Greek mythology who carried souls across the river Styx into the underworld, a fitting partner for the ruler of the farthest dark. Their relationship is one of the most intimate in the solar system. Pluto and Charon are locked in a gravitational embrace so perfect, so absolute, that they forever show the same face to one another. An astronaut standing on the surface of Pluto would see Charon hanging motionless in the sky, never rising, never setting. And from Charon Pluto would appear in the same fixed position a silent marble giant in the black. They are partners in a slow, silent dance, a waltz performed in slow motion across eons forever caught in each other's gaze. For a time we thought of them not as a planet and its moon, but as a double planet, two halves of a single frozen heart, spinning together at the edge of forever. This discovery deepened the mystery, but did not change the core of the story. Pluto was still the end. The binary king and queen ruled together, but their kingdom remained, as far as we knew, utterly empty. The vast, dark expanse beyond them was just that, an expanse. An empty ocean of void separating our solar system from the distant stars. For most of the 20th century, this was the accepted truth. Pluto and Charon were the final lonely sentinels guarding a great nothingness. But the darkness beyond Neptune is vast and patient, and it holds more secrets than one. The technologies of astronomy, like Pluto's own slow orbit, continued their relentless march forward. New telescopes with larger eyes and sharper vision began to peer into that same dark expanse. And as they stared for years on end, they began to see that the lonely king was not so lonely after all. The faint point of light we had watched for so long was not a final destination. It was a signpost. It was the first great landmark in a hidden province of the solar system whose existence we had never even suspected. His kingdom, it turned out, was teeming with subjects. For decades, the solar system felt complete, a familiar and finished map hanging on the walls of our collective mind. The 9 worlds from Mercury's scorched plains to Pluto's distant twilight formed a kind of perfect set. It was a story with a beginning, a middle, and a quiet, frozen end. But science is rarely a finished story. It is a living conversation, and sometimes a faint whisper from the darkness can change everything we thought we knew. The whisper began not with a new discovery, but with a lingering question. A few astronomers looking at the mathematics of our solar system's birth felt that something was missing. They wondered if Pluto was truly the final solitary world. Perhaps they theorized it was not an endpoint at all, but a beginning. Imagine looking out across a vast empty plain and seeing a single distant house on the farthest hill. For years you might believe it is the last outpost of civilization. But what if it were merely the first house you could see of a sprawling hidden village, a whole community of worlds lying just beyond the reach of your sight? This idea of a great ring of icy bodies beyond Neptune was named the Kuiper Belt, after one of the astronomers who helped imagine it. For a long time it remained just that, an elegant theory, a ghost in the cosmic machine. But as our telescopes grew more powerful, our eyes sharpened. We learned to stare into the deep dark for longer, with more patience, searching for fainter and slower movements against the unblinking stars. And in the 1990s, we found the first one, a tiny frozen world designated 1992 QB1. It was nowhere near as large as Pluto, but it was there orbiting in the same distant frigid expanse. The lone house on the hill suddenly had a neighbor. Then came another, and another. Throughout the following years, the census of this unseen village began to grow. We discovered worlds with beautiful mythic names like Makemake and Haumea, objects of significant size, each a unique kingdom of ice and rock, following its own silent orbital path through the outer darkness. The map of the solar system was becoming crowded. The neat, clean edges were beginning to look frayed, complicated. These new discoveries didn't challenge Pluto's place directly. They simply gave it company. Pluto was no longer a beautiful anomaly, a lonely outlier. It was the first, the largest, and the most famous resident of a vast, newly revealed territory. The lone house was now clearly the grandest manor in a growing town. But the discovery that would truly force a new conversation was yet to come. In 2005, a team of astronomers announced the discovery of an object that was without question even more distant than Pluto. But more importantly, through careful observation, they determined it was also more massive. It was a world larger than the one we had called the ninth planet for over 70 years. This new world was eventually named Eris, after the Greek goddess of discord and strife. And the name was fitting, for its discovery cast the neat order of the solar system into a state of profound and necessary confusion. The question could no longer be avoided. If Pluto was a planet, then surely Eris, its bigger, heavier sibling, must also be a planet. And what of Makemake and Haumea? What of the dozens of other large, round objects being discovered in this newly unveiled cosmic neighborhood? If they were all planets, our solar system might not have 9, but perhaps 20 or 50, or even hundreds of them. The familiar map had not just been expanded, it had been rendered obsolete. The word planet, once a term of certainty and grandeur, had become ambiguous. The community of astronomers realized they were facing a problem not of astronomy, but of language itself. To move forward, they needed to agree on a shared meaning. The discovery of Eris and its neighbors had not diminished Pluto. It had revealed the context in which Pluto existed. It had shown us that our solar system was richer, more complex, and more wonderfully strange than we had ever imagined. The challenge was no longer about finding new worlds, but about understanding what they were. To bring order to the map once more, a new definition was required, a clearer way to describe our place among the stars. The world's astronomers would have to gather to deliberate and to ask a question that had not been formally answered in millennia. What precisely does it mean for a world to be a planet? With a new discovery, but with an old question, now asked with new urgency, what truly is a planet? For centuries, the answer felt intuitive. Planets were the wanderers, the bright lights that moved against the fixed backdrop of the stars. But as our vision sharpened, we found more and more wanderers, especially in the cold, dark frontier beyond Neptune. The whisper of a single new, distant world had grown into a chorus of voices from the Kuiper Belt. Our solar system was suddenly more crowded, more complex, and more wonderful than we had ever imagined. And so the map had to be redrawn. This was not a matter of astronomy alone, but of language. It was a story about how a single word, planet, a word inherited from the ancient Greeks, had to stretch and evolve to contain the universe we were now able to see. In the summer of 2006, in the historic city of Prague, the International Astronomical Union convened to have this very conversation. It was not a trial of Pluto, but a thoughtful re-examination of an idea. Scientists from around the world gathered not to cast a world out, but to find a more honest, more accurate way of describing our celestial family. After much debate, they settled on a new definition, a kind of three-part test for planethood. The first two parts were simple enough. A planet must orbit the Sun, not another planet. Pluto, of course, does this tracing its long elliptical path around our star. Second, a planet must be massive enough for its own gravity to pull it into a nearly round shape, a state of hydrostatic equilibrium. Pluto, a perfect sphere of ice and rock, passes this test with ease. It was the third criterion that changed everything. A planet, the Assembly decided, must have cleared the neighborhood around its orbit. This is perhaps the most poetic and powerful part of the definition. It means that a true planet is the gravitational monarch of its domain. Over billions of years it has either consumed, captured, or flung away most other objects in its path. Earth, Jupiter, and the other major planets have done this. Their orbits are their own. But Pluto is different. It is a resident of the Kuiper Belt, a vast, crowded ring of icy bodies. It is the largest object in its immediate vicinity, a king in its own small court, but it has not cleared its neighborhood. It moves among countless peers. Pluto, it turned out, was not a lonely outlier, but the first discovered and most prominent member of a vast new population of worlds. And so, a new category was born, the dwarf planet. It was not a demotion, but a clarification. It was an acknowledgement that the solar system contained more kinds of worlds than our old vocabulary could handle. Pluto was placed alongside Eris, the object whose discovery had sparked this great debate, and others that would soon be found. For many, the news was felt as a loss. The 9 planets had been a comforting, simple truth learned in childhood. But in science, understanding must always evolve. The change was not an ending for Pluto's story. It was the beginning of a far more interesting one. It transformed Pluto from the last smallest planet into the grand prototype of a whole new realm of the solar system. The debate on Earth, carried out in conference halls and classrooms, had given Pluto a new name. But a name is not the world itself. The arguments over definitions and classifications could only tell us so much. They painted a picture in broad strokes, but the fine details remain shrouded in distance, hidden across billions of miles of cold, silent space. To truly know this world, to understand what it meant to be a dwarf planet on the edge of forever, we could no longer be content with simply looking. We had to go there. We had to send an emissary on the long journey into the twilight. While astronomers debated in conference rooms and observatories, a different kind of answer was taking shape. It was not an argument made of words or equations, but one forged from aluminum, powered by plutonium, and guided by the unshakable human desire to simply see. While our definitions of the cosmos shifted like sand, we began to build an emissary, a messenger designed to cross the immense silent sea between our world and the shores of Pluto. This technological pilgrim was named New Horizons. It was a compact traveler no larger than a grand piano, but packed with the sharpest senses humanity could devise. It carried telescopes to see in light, both visible and invisible spectrometers to taste the thin atmosphere and imagers to map the unknown terrain. It was not built to orbit or to land or to return. Its destiny was a fleeting one to perform a single breathtaking flyby, a glance over the shoulder at a world we had only ever known as a point of light, and then to continue on into the endless dark beyond. In the crisp air of a January morning in 2006, it left Earth climbing into the sky on a pillar of fire. It was the fastest object ever launched by human hands, a testament to the urgency of its quest. It shed the weight of our world's gravity and began its long, lonely coast outward. Its journey would take 9.5 years. It would cross 3 billion miles of cold, empty space. A child born on the day of its launch would be ready for grade school by the time its signal reached home from Pluto. For most of this immense journey, the emissary slept. To conserve power and protect its delicate systems, its electronic mind was put into hibernation, waking only for brief, periodic check-ins with its distant creators. It drifted in silence, a solitary seed of human curiosity tumbling through the void. But its path was not a simple straight line. It was a masterpiece of celestial navigation. Just over a year into its voyage, New Horizons approached the colossal king of the planets Jupiter. It did not slow down to visit. Instead, it performed a graceful cosmic dance, using Jupiter's immense gravity as a slingshot. It skimmed past the gas giant, borrowing a sliver of its orbital energy, flinging itself forward with a tremendous boost in speed that would shave 3 full years off its travel time. It was a maneuver of exquisite precision, a whisper of guidance sent from Earth years before, executed perfectly in the silent theater of space. And aboard this silent messenger, a passenger of profound significance made the journey as well. Secured to the spacecraft's upper deck was a small aluminum canister carrying a single ounce of ashes. They were the remains of Clyde Tombaugh. The farm boy from Kansas, who had scanned the heavens with tireless patience, was finally on his way to the world he had found. The inscription on the canister was a quiet tribute, not just to a scientist, but to a human being. Interned herein are remains of American Clyde W. Tombaugh, discoverer of Pluto, Adele and Muron's boy Patricia's husband Annette, and Alden's father astronomer teacher, punster, and friend. The discoverer was at last making the pilgrimage to his discovery, a final poignant closing of a circle that had begun nearly a century before. As the years passed, the sun shrank behind it, becoming just the brightest star in a sea of stars. In the final year of its journey, the command was sent to awaken. Across the solar system, the silent traveler came to life. Its systems hummed, its instruments warmed, and its eyes turned toward the faint, steady light ahead. The dot that Tombaugh had found, the dot that had puzzled astronomers for decades, began to grow. First, it was a single pixel, then 2, then a fuzzy, indistinct blotch. With each passing week, the blotch gained character. It resolved into a sphere. Patches of light and dark appeared on its surface, hinting at a complexity no one had dared to imagine. The 9-year silence was ending. The 3-billion-mile journey was approaching its destination. The emissary had arrived, and it was time for it to show us the face of the world that had waited so long in the dark. This technological pilgrim was named New Horizons. For nearly a decade it traveled in a state of electronic hibernation, a silent vessel arcing through the darkness, covering millions of miles with each passing day. It flew past the orbit of Jupiter, then Saturn, Uranus, and Neptune, leaving the familiar lights of our solar system far behind. On Earth, the world changed. Seasons turned, societies evolved, children were born and grew up. But out in the cold vacuum, New Horizons sailed on its single purpose, unwavering to keep an appointment with a world no human eye had ever truly seen. Then, in the summer of 2015, the long silence ended. The spacecraft awoke, its instruments cold and dormant for so long warmed to life. And on July 14th, after a journey of 3 billion miles, New Horizons kept its promise. For a few brief, breathtaking hours, it soared through the Plutonian system, a fleeting encounter that would forever change our portrait of the outer solar system. The Data began its long journey home, a 4.5-hour cascade of light-speed information, crossing the immense void to listening dishes on Earth. And as the first images resolved on screens in mission control, a collective hushed awe fell over the room. The blurry pixel, the faint smudge that had defined Pluto for 85 years, was gone. In its place, a world of impossible beauty and startling complexity bloomed into existence. There, emblazoned across one hemisphere, was a feature so vast and so unexpected it seemed like a message, a giant, brilliant heart etched onto the surface. This was not the uniform cratered wasteland many had predicted. This was a declaration. Named Tombaugh Regio, in honor of its discoverer, this heart-shaped plain was a stunning expanse of frozen nitrogen, carbon monoxide, and methane. But it was not a static feature. Scientists would soon realize they were looking at the surface of a gigantic, slowly churning glacier. Like a pot of water simmering on the lowest heat, vast polygonal cells of nitrogen ice were convecting, rising and falling over millions of years, erasing craters and constantly renewing the surface. Pluto had a beating heart. The revelations continued, each new image a brushstroke on a masterpiece no one had dared to imagine. Near the edge of the great heartland rose mountains. Not mountains of rock, but colossal peaks of water ice, frozen to the hardness of granite in the unimaginable cold. Some of them stood as tall as the Rocky Mountains on Earth, their icy summits scraping the heavens of this distant world. Named Hilary Montes and Tenzing Montes after the first conquerors of Everest, they were monuments to a geology that was utterly alien, yet strangely familiar. How could a world so small and so far from the sun have the energy to build mountains? And then, as New Horizons looked back, it saw one last ethereal gift. It captured an image of Pluto silhouetted against the distant sun. And there, ringing the dark sphere, was a soft, glowing halo. An atmosphere. It was thin, to be sure, but it was complex with more than a dozen distinct concentric layers of blue haze created as sunlight interacted with the nitrogen and methane gas. It was a delicate sapphire twilight on a world at the edge of night. The images hinted at even more strange pitted terrains, flowing glaciers of exotic ices, and even the possible signs of cryovolcanoes. Volcanoes that spewed a slurry of water, nitrogen, and ammonia from the world's warmer interior. This was not a dead world. It was not a simple frozen relic. It was active. It was dynamic. It had weather geology and a beauty that rivaled any of the major planets. The little point of light that Clyde Tombaugh had found the world that had been defined by debate and emotion had finally spoken for itself. And its statement was undeniable. It was a place of profound and ongoing wonder. The argument was no longer about what Pluto wasn't. The data streaming back across the void demanded a new conversation entirely. What exactly was it? This was not just a world. It was an archetype. Lent messenger coasting on a trajectory calculated years in advance. And then, in the summer of 2015, after a silent voyage of 3 billion miles, it arrived. For a few precious hours, New Horizons awoke completely, its electronic senses trained on the pale, distant world it had traveled so long to meet. It was a fleeting encounter, a high-speed flyby, with no chance to slow down, no opportunity to linger. Every instrument, every camera, every sensor worked in perfect concert to capture as much of Pluto and its family of moons as possible, before plunging back into the darkness beyond. The data captured in a brilliant flash of observation then began its long, slow journey back to Earth, a whisper of binary code traveling for over 4 hours at the speed of light to cross the gulf of space. When the first detailed images resolved on screens in mission control, they were met with stunned silence, then quiet awe. This was no simple cratered ice ball. Before us lay a world of breathtaking complexity. There were vast, smooth plains of frozen nitrogen shaped like a heart and sprawled across 1,000 kilometers. There were towering mountains of solid water ice, rivaling the Rockies on Earth, thrusting up into a sky tinged with a delicate blue haze. There were canyons that scarred the surface and strange bladed terrains that looked like nothing seen before in our solar system. Pluto was alive not with biology, but with geology. It had weather, it had flowing glaciers of exotic ices, and it had a past and a present written across its face. The revelation was profound. It was as if we had discovered a celestial Rosetta Stone. For decades we had seen the outer solar system as a sparse, quiet place populated by leftover debris. But the message from Pluto taught us we were reading the wrong language. This distant world was not an outcast, not the final, lonely outpost of our solar system. It was the capital of a new, undiscovered country. Pluto was in a sense the king of the Kuiper Belt, a vast ring of icy bodies orbiting beyond Neptune, a third realm of our solar system that we were only just beginning to comprehend. The term dwarf planet suddenly transformed. It was no longer a demotion, a consolation prize for a world that failed to meet a new standard. Instead, it became a promotion. Pluto was the archetype, the magnificent first example of the most common type of world in our solar system. There are likely thousands of others like it, orbiting in the cold twilight worlds like Eris Makemake and Haumea, each a potential kingdom of its own with its own secrets. These are not failed planets. They are a vibrant, successful class of world built from the original ingredients of the solar system, preserved in a deep freeze. And the story told by Pluto's surface hinted at an even more astonishing possibility. To power such active geology to push up mountains of ice, a world so far from the sun must have a source of internal heat, likely from the slow decay of radioactive elements in its core. That warmth could be enough to maintain something extraordinary beneath its frozen crust, a vast, dark ocean of liquid water. The very ingredient we associate with life hidden away in the last place we would have thought to look. Having delivered its revolutionary message, New Horizons did not stop. Its brief, glorious encounter was over, and it sailed onward a silent emissary, carrying the greetings of humanity deeper into the Kuiper Belt. It is a pilgrim still traveling today, pushing into the great uncharted darkness, its instruments now aimed at even more distant and ancient objects. Pluto gave us the key, the ability to understand this cold, distant realm. It taught us that the solar system did not simply end with Neptune, but opened up into something far richer and more complex than we had ever dreamed. This profound shift in understanding was more than just a matter of science. It was a matter of perspective. It forced us to redraw the maps of our own cosmic neighborhood. The names and categories we had created, the neat and tidy boxes we used to organize the heavens, were shown to be beautifully, wonderfully incomplete. Our language had to stretch to evolve just to accommodate the reality of this one small world. And in doing so, it raised a question that echoes far beyond the orbits of planets, a question about how we see, how we define, and how we know. It reminds us that the edge of our knowledge is also the edge of our language, compelling us to ask what truly lies in a name, of this fleeting moment as possible. Then, as quickly as it began, the encounter was over. New horizons sailed past, turning its antenna back toward a home it would never see again, and began the long, slow process of sending its secrets across the void. The data trickled back to Earth over months, a ghostly transmission whispered across billions of miles. And with each packet of information, the portrait of Pluto sharpened from a fuzzy point of light into a world of breathtaking complexity. What we saw was not a simple frozen cratered ball of ice. It was a revelation. We saw a vast heart-shaped glacier made of nitrogen ice, a plain younger than the Himalayas, suggesting a world that was geologically alive. We saw towering mountains of solid water ice, capped with methane snow, rising from the surface like frozen sentinels. We saw a thin, hazy atmosphere, tinted a soft, ethereal blue, a delicate veil clinging to a world at the edge of night. Its largest moon, Charon, was no less stunning, with a mysterious dark polar cap and a canyon system that dwarfed the Grand Canyon on Earth. This was Pluto, not the ninth planet, not a dwarf planet, not a Kuiper Belt object. It was simply itself, a place of profound and unexpected beauty, a world with a story written in ice and shadow. And so, the old debate, the one about names and categories, suddenly felt small in the face of such wonder. For so long we had argued about what to call this distant object. Was it worthy of the title, planet? The discussion was a human one, born of our need to classify, to order, to fit the cosmos into neat, tidy boxes. But the universe, it seems, does not much care for our labels. A change in name does not alter the nature of the thing itself. A rose by any other name would smell as sweet, and Pluto by any other name would still have mountains of ice and a heart of nitrogen. The reclassification was never a demotion of Pluto. It was an expansion of our own understanding. We had discovered that the solar system was richer and more varied than our 9-box model could contain. We needed new words because we had found new kinds of worlds. Think back to the metaphor of our solar system as a vast, dimly lit room. For centuries we were content, studying the familiar furniture near the center, brightly lit by the sun. Pluto was just a rumored shape in a far dark corner, a faint suspicion. For decades after its discovery, it was a blurry smudge, something we thought we understood. We drew a simple circle around it and gave it a name. But with the journey of new horizons, we did not just get a closer look. We crossed the room carrying a brilliant lantern and held it up to that forgotten corner. And what we saw was not a simple dusty object. It was a world intricate and shimmering. The light of our new knowledge revealed not an ending, but a beginning. It showed us that this corner of the room was filled with countless other fascinating objects, a whole new category of existence we had barely begun to comprehend. The story of Pluto taught us the most vital lesson in all of science: humility. It reminded us that our maps are not the territory, and that the greatest discoveries often lie not in confirming what we know, but in gracefully accepting what we do not. The journey of this small world from a mathematical prediction to a faint photographic plate, from a planetary king to a celestial wanderer, is a mirror for our own journey of discovery. It is the story of looking deeper, of refusing to be satisfied with easy answers, and of finding more beauty in a complex reality than in a simple myth. New Horizons continues its voyage, even now coasting deeper into the Kuiper Belt, a silent ambassador in the dark. It carries our curiosity with it, a promise that we will keep looking, keep questioning, and keep wondering. Pluto is no longer just a name, a number, or a debate. It is a place, and its story is a quiet, powerful reminder that the universe is not finished with us. At the very edge of what is known, where the light grows thin and the silence is absolute, there are still worlds waiting. Worlds that will challenge our definitions, expand our minds, and fill our imaginations with a beauty we have not yet learned to name.